Hello everyone. This video would focus on conic section, specifically on parabola, and this is the second part. In this part, we're supposed to determine the equation of a parabola given the vertex and a focus, and we're supposed to sketch the graph. Before we go over this example that we have right here, let's have a review on the basics of parabola with vertex at point of origin or at 0, 0. There are 4 cases of a parabola with vertex at 0, 0, and this is the first case right here. Before we go over the details of the first case, let's have the parts of a parabola. These are the parts of every parabola. The first one is the directrix, which is represented as a broken vertical line right here. And this is the vertex. Again, our vertex is at the point of origin 0, 0. This is the focus, and this is the line of symmetry. Please remember that the distance from the directrix to the vertex is represented as P. So I'm just going to go ahead and label that up here. So this is represented as letter P. Now the distance from the vertex to the focus is also represented as P. So this is another P right here. This tells us that for every point on the parabola, the distance from the directrix to the focus would always be the same. Meaning if we take this point right here, the distance from the directrix and the distance from the focus, these two will be the same. And that is true for all the points on the parabola. Now we also remember that if we draw a line perpendicular to the focus passing through the, or perpendicular to the line of symmetry passing through the focus, this is what we call as the latus rectum. So I'm just going to go ahead and label that up here. Now we remember that the distance from the one of the endpoints of the latus rectum to the focus is 2p. And the distance from, again, the other end of the latus rectum and the focus is, again, the distance is 2p. So pretty much the length of the latus rectum is 4p. Now we also remember that for every parabola, it will open towards where the focus is. So in this case right here, since our focus is on the positive x-axis, so the parabola will open on the right. Now, the formula that works for the first case is y squared equals 4px. So this is the formula for the first case. Now let's look at the second case. In the second case, the parts of the parabola would always be the same. We have the directrix, the vertex, the focus. This is the line of symmetry, and this is our parabola right here. If you notice, the parabola on the second case opens to the left since the focus is on the negative x-axis. Again, remember that the parabola opens to the side where the focus is. The formula that would work for the second case is y squared. It's pretty much the same thing as the first one. That's y squared equals 4px. So this is the formula that would work for the second case. Now let's move on to the third case. For the third case, the parabola opens upward since the focus is on the positive y-axis. We also have the directrix. Again, we have the vertex at the point of origin 0, 0, and we have here the axis of symmetry. Now, the formula that would work for the third case, again, whenever the parabola opens upward, is x squared equals 4p y. So this is the formula for the third case. Now let's move on to the fourth case. In case 4, our parabola already is facing downwards. It opens downward because the focus is on the negative y-axis. And we still have the same parts. We have the directrix, we have the vertex, and we have the focus, and the line of symmetry is the y. The formula for the fourth case is pretty much the same as the third case. That is x squared equals 4 py. So this is the formula for the fourth case. So these are the four cases of the parabola with vertex at the point of origin, or 0, 0. Okay, going back to the example that we have right here, we're supposed to determine the equation of a parabola with vertex at 0, 0 and focus at -3, 0. And we're supposed to sketch the graph. So the first thing that we are going to do here is to sketch these 2 points that we have right here, the vertex, which is the point of origin, and this focus that we have here. So at vertex is 0, 0. So I'm going to label this as the vertex. And then the focus is located on -3, 0. So that would be x -3 and 0. So this is our focus. Now, looking at these two dots right here, we can tell that the parabola opens to the left, since we remember that parabola will open towards where the focus is. Since this opens to the left, we can go ahead and say that this is case number 2. So I'm going to go ahead and write that down here. Now, looking at these 2 points right here, we remember that the distance from the vertex to the focus is represented as letter P. Now, since this is going to the left of the vertex, we can go ahead and say that our P is -3, because that's 3 units to the left. Now, looking at the equation for case number 2, that is actually y squared is equal to 4px. Now, we are going to plug in the -3 to the p and solve for the equation. So this is how it's going to look like. So that's y squared is equal to 4. We put in the p right there. Again, our p is -3. So I plug the -3 in there. And so this comes out y squared is equal to -12x. And this is the equation for this parabola that we have in this problem right there. So we can go ahead and sketch the graph here. We remember that the ends of the latus rectum is twice the p. So I'm going to go ahead and write that down here. So from the focus, we are going to count 2p up and 2p down. Since our p is 3, 2 times 3 is 6. So that would go up here. And 2 times 3 is also -6 right here. So it's going to go down here. So these are the ends of the latus rectum. So the coordinate of the ends of latus rectum is -3, 6, and the other end is located at -3, -6. So I'm just going to go ahead and write that down here. So that's the ends. These are the 2 ends of the latus rectum. So we can go ahead and sketch the graph. So this is the sketch of this equation. Y squared equals -12x. Notice again that the vertex is at the point of origin 0, 0, and the focus is at -3, 0. Now let's move on to the second example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're going to sketch these 2 points right here. The vertex is at 0, 0. So this is our vertex. And then the focus is located at 0, 7 halves. 7 halves is 3.5. So I can go ahead and put that point right here. So that's 1, 2, 3. 3 halves would be this way right here. So this is our focus. From here, we can go ahead and say that this parabola opens upward, because again, we remember that the parabola will open towards where the focus is located, so that we can go ahead and say that this is an example of case number 3 since it opens upward. So I'm going to go ahead and write that up here. We remember that the distance from the vertex to the focus is represented as letter P. Since it's going up, we can take our P as positive, and that is the distance from vertex to focus is 7 halves. So I will put that down here. So that's 7 halves. Now, the next thing that we are going to do is to write the formula for case number 3. So the formula for case 3 is... Okay, so we are going to plug this value of P into here so that we can come up with the equation. So this is how the equation is going to look like. Okay, so the equation of this parabola is x squared is equal to 14y. Now we are going to determine the ends of the latus rectum. We can determine the ends of latus rectum in 2 ways. The first method is, just like the first example, we are going to double the value for P because the distance from the focus to the end of latus rectum is twice the P. We can do that, which would equal to 7. So I'm just going to go ahead and show the work down here. So the value for 2P is 7. So this tells us that the first end of the latus rectum is 7 steps to the left and 7 steps to the right. So this is how it's going to look like. So these two right here are the ends of the latus rectum. Now the other way to solve for the ends of latus rectum is using the original equation that we have right here. But this time around, we are going to plug in the value of P into the Y. So I can go ahead and plug that in here. So this is the other way. So I'm just going to go ahead and put OR on that one. So this is the other way to determine the ends of the latus rectum. If you notice, the value of or the length of the latus rectum is the same for both. It's going to be positive 7, negative 7. So that means 7 to the left and 7 to the right. So I'm just showing you the 2 methods of determining the ends of the latus rectum so that we can go ahead and sketch the graph of this equation that we have right here with the vertex at 0, 0 and the focus at 0, 7 over 2 or 7 halves. So this is the equation of the parabola, and this is the graph of this parabola given this problem that we have up here. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!